Assalamualaikum warahmatullahi wabarakatuh. Good evening, ladies and gentlemen. I would like to say thank you for coming in my presentation. Let me introduce myself. My name is Linggasari, and I'm from ISNPINSA. In this opportunity, I would like to present my research paper entitled Evaluation of Dosimetry in Case of Breast Cancer Post-Mastectomy with or without bolus based on silicone rubber using intensity-modulated radiation therapy. The table of content that I will convey consists of introduction, material and method, experimental result and discussion, and then conclusion. The first is introduction. Based on the data from the Pathology Breast Cancer Registry in collaboration with the Indonesian Cancer Foundation, shows that breast cancer in Indonesia is ranked second of all types of cancer that often suffer. Currently, the treatment for breast cancer is quite diverse, such as conservation surgery, radiation therapy, chemotherapy, surgery, and hormone therapy. Mastectomy is the surgical removal of the breast to remove cancer cells in the face. In general, mastectomy is followed by radiation therapy or called post-mastectomy radiation therapy or PMRT. It's aiming to remove the remaining cancer cells so the risk of the recurrence is not so high. In PMRT treatment, when the cancer is on the skin surface, radiation therapy using photon is not easy to achieve the appropriate dose in the skin surface area. Therefore, a replacement bolus is needed to overcome the problem during the treatment process. One of the alternative materials used in the manufacture of boluses is silicone rubber. Therefore, in this study, a bolus made of silicone rubber with a thickness of 0.5 cm was staged to be applied to PMRT cases using the IMRT technique. The bolus test carried out included the density test and the percentage of surface dose. In addition, the study also evaluated the surface dose volume histogram, and dose profile in cases of PMRT with or without bolus. The second is material and method. The first method is bolus verification. The first step was the measure of RT-PCC silicone rubber and the catalyst volume 100 ml and 3 ml respectively. And then the catalyst was poured to the silicone rubber, and then stirred slowly for 1 minute using mixer. And then silicone rubber and the catalyst was poured into the acrylic mold. And after that, wait until the solid fills and remove from the mold when the bolus was solidified completely. The next method is bolus density test. The first step is the CT scan process is carried out to take image of the phantom thorax with and without bolus. And then the second, the image result sent to the treatment planning system computer to determine SU value. And then the third, the SU value is in the bolus image is determined by making the region of interest rectangular. And then the last, the SU value is converted to relative electron density value to the water. The next method is ABT3 radiochromic film calibration. The first step is film calibration. Film calibration test is conducted with exposure of photon source 6 MP. And then the second, ABT3 film is scanned using Epson scanner 10,000 XL at MRCCC Siloam, South Jakarta. And then the last step is measurement of pixel values with imaging, then change to NetOD. The next method is bolus surface dose. This is an illustration of collecting data in process bolus surface dose test. The EBT3 film was irradiated perpendicular to the solid water phantom using 6 MV photon beam linac with an irradiation field area of 10 by 10 square centimeter. The last method is measurement of surface dose on the phantom thorax. The first step is CT scan phantom thorax with and without bolus, and then the second step is treatment planning system using Eclipse software with IMRT technique 5 fields. And then the last step is placement of EBT3 film and irradiation on the phantom thorax. EBT3 film is placed at 3 points, right point, center point, and left point. After the film was placed, irradiation was performed using a linac with 6 MV photon beam. And then the next is experimental result and discussion. Table 1 is the reference value of relative electron density of water and some tissue. And then this is the RED result in this study. If the result of two are compared, it can be seen that the RED bolus value with silicone rubber material is higher when compared to soft tissues such as muscle, breast, and adipose. Then, if the RED bolus is compared to dense tissues such as thin bone, the RED bolus made up from silicone rubbers is lower. Next is result of EBT3 film calibration. The calibration curve of each channel shows that the net OD value on the red channel has the larger net OD value, which means it has the highest response. Next is the result of bolus surface dose test. Based on the percentage of surface dose beside, it can be analyzed that the PSD value of bolus increased by 50.28% to the surface dose without bolus, which was 29.75%. And the next is result of this all of dose volume histogram and organ at-risk. This is the pH in PTV chest wall, heart, lung, and lung artery, and spinal cord. It seems like was almost the same. And then this is analyzed percentage of total structural volume on OR. The result obtained indicate that the percentage of total volume for the right lung and heart, either with or without bolus, made of silicone rubber, is included in the tolerance range used. Next is the result of dose profile. Based on the dose profile curve obtained at all points, the dose will change when the silicone rubber bolus material is stated, where the value of the dose achieved will be even greater. The last one is the value of the surface dose on the phantom thorax. Based on the surface dose value obtained, the surface dose value increased up to 35% along with the addition of the bolus material. And then the last is conclusion. Based on the result obtained in the study, it can be concluded the first silicone rubber bolus with a thickness of 0.5 cm could increase the PSD value up to 80%. And then the second, DPH on TPH result, both without bolus and using bolus, met the optimization of radiation recommendation according to ICRU 662 for PTV chest wall and OR were also below the permissible dose tolerance limit. And then the third, based on the obtained dose profile curve, the surface dose distribution increased when the bolus was stated. And then the last, bolus made of silicone rubber with a thickness of 0.5 cm can increase the value of the surface dose up to 35%. Therefore, it can be concluded that the bolus made of silicone rubber with a thickness of 0.5 cm is suitable for increasing the surface dose in cases of post-mastectomy breast cancer. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.